3.3 rules for differentiation. All right, we're going to have 6.
Okay.
So the derivative of a constant function is df dx is equal to d dx of c, where c is just a constant, and that's equal to 0. So the derivative of any number, positive, negative, irrational, whatever, is 0. So, what is the derivative of 5?
0.
What's the derivative of e?
0.
0. Good. Thank you for realizing that e is a number.
And pi,
What
too.
number?
And pi is a number. 2.717. So on and so forth. There can almost guaranteed be a give me question
I love
of a
that.
constant
It's like, oh, I know
on
that
your
one.
test.
It's like, oh, I know.
Don't get it
that
wrong.
one. Yay.
Melter.
I love that he's always
He like messaged me after I sent like Jake home and like told him about that. He like messaged me and he was like, he's like, I'm being used as an example, huh? I was like, yep.
Yep.
I was like, you always will be. All right. Next we have the power rule for positive integer powers of x. Now, this is the exact same rule that applies even if it's negative. So just be aware of that, but they're doing it for technically it being positive. It is d dx of x to the n. So x would be the variable, n is the power. And that is going to be equal to n x to the n minus 1. So we just subtract 1 off of the exponent.
Is that not what we've already been doing? Is that what we've already been doing?
Yeah, I just taught you the shortcut early.
Okay, I was like, wait, that was for me.
Yeah, no, I just taught you the shortcut early
Okay.
because it really irritates me having to do it the long way. Once you know how to do the short way, it's like, do I really have to do this?
Why?
Because you can literally find the derivative at a point by just doing this.
Yeah.
But the long way always works, regardless of, like, when you get to the quotient rule and stuff like that.
I'm like,
The long way is kind of like your foolproof method.
Yeah.
But,
I don't need foolproof. I need shortcuts.
all right, your constant multiple rule. So this is a little different than the derivative of a constant function. So if u is a differentiable function of x and c is constant, then d dx of cu is equal to c times du dx. So we would take the derivative of whatever the function u is with respect to x. So essentially what this would be a scenario of is like you have a function that you can take a constant out of, and then you take the derivative of that value, or of the rest of the function that was left, but you're still multiplying it by whatever that constant number was.
okay.
So it's kind of hard to like probably picture, but it's pretty easy. All right, sum and difference rule. We've basically already done this as well. It's just going to be written a little differently. So d dx of u plus or minus v. Also, you're going to hate this because a lot of stuff is done in u's and v's. And I try to make them obnoxious with a point or rounded, but sometimes they look similar. So if you're ever not sure, just ask. All right, so basically all this says is we're taking the derivative of u plus or minus the derivative of v, which is u and v are just functions with respect to x. So it would be du dx plus or minus dv dx. So the sign doesn't change unless it had a negative exponent, but they're assuming, I think, everything has a positive exponent right now. I want to say negative exponents might not be until, 3.4 doesn't have negative exponents. Nope, oh, wait. I lied. There's still more sections, not just 4.
Oh.
There's 5 sections in this chapter. So yeah, so after 3.3 there'll be a quiz. I don't really know when we do negative exponents. I think they kind of just throw them in, but it follows the same rule. But that would be the only time the sign is changing, is if you had a negative exponent potentially on one or the other. But so far, these rules should kind of just more or less logically make sense. The next rules, you might have to think about a little bit.
Quotient product rule.
Yeah. All right, so the product rule. So this is basically if you're multiplying like two functions together, or like two things in parentheses, like when we have like 3 plus x times 2 minus x, it's kind of like a way to do that without having to multiply it through and then take the derivative. But your answer should end up being the same, technically, whichever way you do it. But so d dx of u times v. So u times v, those are basically just saying those are two functions, again, and they are differentiable functions. Obviously, we can have ones that aren't. So the derivative of this is u times the derivative of v, so dv dx, plus v times the derivative of u, so du dx. So it's the first times the derivative of the second plus the second times the derivative of the first. So as long as you get all the pieces, or like as long as you get them both in there, it doesn't really matter which one you do first, but it's easier just to learn it that way. Now, I'm going to write it with primes as well because I think sometimes it's a little easier to see. And a lot of times I'm going to say like uv prime.
Okay.
Or something like that when we start doing problems. I'm not going to be like, well, dv dx times u or whatever, you know. So uv prime is equal to u v prime plus u prime v. Now, I wrote that backwards from how I wrote it in the top, okay? But what it's supposed to tell you is that if you copied it down exactly both times, like, see, it's uv, so it's uv and uv. The inner two pieces are what you take the derivative of, is what it's trying to tell you.
Okay.
So that's why we write it that way. The other way writes it flipped, which is why I will typically do it this way.
Yeah, that way makes more sense.
Because it's more of a visual, like I'm a visual person, so it's more of a visual for me to see.
Like I can see those two on the inside.
Yeah,
so
they're on the inside.
Okay.
And then the nice thing is with the quotient rule, it's the ones on the outside that are going to get done. So
Nice.
it'll kind of help also. But with the product rule, as long as you know that it's 1 times the derivative of the other plus the derivative of the other times the 1, like, it doesn't really matter what order. Quotient rule, however, does matter. Order does matter. It's very critical. So the quotient rule all right, quotient rule. I thought you were trying to get him something. I was like, what? I was like, what is happening? So I'm not even going to write this one with the dv's and the du's. I'm going to write it as d dx of u over v. But I'm going to rewrite this as u over v prime. So I'm going to write it as it should be, and then I'll tell you how I will verbally say it typically when we're doing it. So it's u prime v minus uv prime divided by v squared. And obviously assuming v is not equal to 0. So I'm going to write in words on here so that you have it for reference. But what I will say is the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. Okay,
That
so
order matters.
yes, because of the minus sign, it matters. So whatever's on the bottom will always be squared on the bottom. The top, the reason I like the way we wrote the product rule up here is because now it's written the same way except for we're priming on the outside. We're taking the derivative of the outer two, whereas on product rule we're taking it of the inner two. So I will say the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. So these aren't all the rules that we'll have for differentiation, but that's all for now. Section 5 that has derivative of trig functions, those kind of just have to memorize. So make sure you know these rules, specifically the product rule and the quotient rule, because if you don't, you're going to be in trouble. Unless you decide to go somehow do it the long way, but it won't. These aren't typically going to be giving you the derivative at a point. I mean, they could, but they're typically just going to say take the derivative. I'm going to say that, and then the first problems are going to be at a point. Oh, no, it's not.